let's tie definite integrals in to a broader meaning, and we'll be able to perform some applications on some word problems. The net change of a rate. So here's what I mean by that. When the function that we're performing the definite integral on, is a rate. The definite integral is the net change from A to B. Okay, I'm just going to give you a drawing with some units here. Make sense of this. Let's say I've got this graph. So let me go into detail what this is. Let's say you drive for 2 hours. Okay, so down here I've got hours, and up this way I've got miles per hour. So the function that's drawn there is a rate. It's a velocity, miles per hour. This is 65 miles an hour because I know you would never go above 65. What's going on here? Okay, so beginning of your trip, you get in your car, time 0, and obviously you're not moving. So then you start to move, and you're going pretty slow through your neighborhood, and then you get to the freeway, you get to the on-ramp, and you accelerate up to 65, or maybe a mile or two below. So then you're kind of at 65 for a while, time's passing, half an hour or so, and then you come into some traffic, right? You come into LA, something like that. You slow down, you're slowed down for a while. You're never stopped, but you're definitely going maybe like 40 miles an hour. Okay, then the traffic clears and you're back up to speed and everything's good, and okay, you're coming up to your destination, so you exit the freeway and you're slowing down pretty quick to hit that red light. Now you're stopped at the red light, so you're at 0 miles per hour. Then okay, light turns green and you keep going again, and then here you finally reach your destination after exactly 2 hours. All right. What would it mean to find the area between this function, whatever it is, and the x-axis? What does all of that area represent? What would it mean in the context of hours, miles per hour, right? This is crazy. Check this out. Still think, width times height. Okay, just like in the average function value thing. The width is hours, the height is miles per hour. If I multiply them, I get the units for the area. What does that area represent? Well, miles per hour times hours. Don't the hours cancel? And I just get miles. If I was to find the area here, that tells me exactly how far I have traveled. It's the net change in my position. It's my distance from the time I began to 2 hours later. How far did I travel? That had to be a rate. That turned out to be my distance. Wow, that is amazing. Hey, I don't even have to do the whole thing. What if, so about right here looks like about 1 hour, right? So let's say 1 hour is right there. So maybe I say like this is half an hour, and over here is like an hour and a half. Okay, 1.5. What if I just wanted to know how far I traveled, from like 30-minute mark to 60-minute mark, like from the half hour moment to the 1 hour moment? I could just find this area only, right? And that would be how far I traveled from the 30-minute mark to the 60-minute mark. So it doesn't have to be the whole thing. This is so cool. All right, the net change. Here we go. Word problem. Let's get that off the screen. The rate of increase in maintenance costs of an apartment building is described by this, and it's a rate. I think I've got more. Okay. M prime of x. So the rate of increase, how fast are the costs increasing? So, costs don't stay the same usually. As the apartment gets older, more things need to be repaired more frequently. Also, tools or replacement parts get more expensive over time. So we would expect to be paying more and more and more as the years go by. Where X is the age of the building. So, at first, just kind of ponder this for a moment. When the building is brand new, right, X is 0, and, say we're paying $5,000 per year. I don't know if that's what we're thinking here, but it'd be 5,000, right? Well, after 1 year, how much are we paying? 1 year later, it's 5,090, right? Things are, starting to break a little bit more. Things are getting a little bit more expensive. It's only getting more expensive as time goes by. So that's the rate of increase. Here's the question. Find the total maintenance cost from year 2 to year 7. How much total money are we going to spend, or can we anticipate spending, from this moment in time to this moment in time? Here's how we're going to do it. It's a definite integral from 2 to 7 of our rate of maintenance costs, 90x squared plus 5,000 dx. How is this going to get us the total maintenance? Think about the units, okay? So it didn't name the, well, it says years here, right? So this is like dollars per year right there. What does dx represent? So remember, dx, it's an infinitesimal change in the x value. What does the x value represent? The age of the building, years. So we're doing dollars per year times years. Well, what are we going to get when we're done? Dollars. And then we're like adding all of those up for each little tiny little infinitesimal increment from 2 to 7 years. Oh man, that's so awesome. All right, here we go. We can knock this thing out. Let me keep this up on the screen so we can see the steps. Here's the next step. Well, we need an antiderivative. Well, let's see. That would have come from x to the third. 20. It's not going to be 20. What am I doing? What am I doing? Getting tired or something. 30, because the 3 would multiply to get the 90. Okay, 30x to the third plus 5,000x. Evaluate that from 2 to 7. And I think I've got to probably correct that mistake a couple more times. 30. We'll plug the 7 in. We'll subtract. We'll plug the 2 in. And I'm definitely going to have to change my answer here. My mistake. This is all going to be... I was so excited about dollars per year and everything. Okay, so 30 times 7 to the third plus 5,000 times 7. I got 45,290 right there, minus 30 times 2 to the third plus 5,000 times 2, 10,240. And subtracting those, I got 35,050. From year 2 to year 7, over that 5-year period, we can expect to pay a total of $35,050 if our function is correct. Pretty good estimate anyway, probably. All right. Hey, we finally reached the end of 5.5. Go check out the homework. See you in the live meeting.